Alright, the polynomial 2x cubed plus mx squared plus nx plus 2 has a factor of x plus 1. When divided by x plus 2, the remainder is 1. What are the values of m and n? So this is like an application of the remainder theorem, also the factors theorem, which is a subset of the remainder theorem. Now, we can understand that if I let f of x represent our polynomial, 2x cubed plus mx squared plus nx plus 2, we know that one of its factors are x plus 1. So if I plug in f of negative 1, I should get 0 according to the factor theorem. Excuse me. So if I plug in f of negative 1, I get 2 times negative 1 cubed plus m times negative 1 squared plus n times negative 1 plus 2, which is negative 2 plus m minus n plus 2, and this should be equal to 0. Okay? So if I try to equate this, negative 2 and positive 2 cancel out, so m minus n is equal to 0. This gives us one set of equations. We have two variables. We can't solve this yet. We can notice that m is equal to n. Okay, we can also use substitution if you don't want to use elimination. We also know that when divided by x plus 2, the remainder is 1. So f of negative 2, according to remainder theorem, is 1. If I plug in f of negative 2 into the function, you get 2 times negative 2 cubed plus m times negative 2 squared plus n times negative 2 plus 2 is equal to 1. Okay, and then what I want to do, if I expand this out, 2 times negative 8 is negative 16 plus 4m minus 2n plus 2 is equal to 1. And then I'm going to combine negative 16 plus 2, so 4m minus 2n minus 14 is equal to 1. I'm going to move the 14 to the other side. 4m minus 2n is equal to 15. This is equation 2. And then what I want to do here is I can either use elimination or substitution. I'm just going to use substitution. According to the first equation, m minus n is equal to 0. So because of that, m is equal to n. I'm going to substitute this into equation 2. So we get 4n minus 2n is equal to 15. 2n is equal to 15. So n is equal to 15 over 2, which is 7.5. If you want to solve for m, you just plug this in. So I'm going to substitute this into equation 1. But we know that m is equal to n, so m should also be 7.5. Okay, so m is 7.5, n is 7.5 as well. Okay, so those are our solutions for m and n.